Hi, everyone. Welcome to the Mojaloop Fraud Risk Management feedback session after our last program increment. This would be our 6th presentation to the Mojaloop community. I'm Justice Ortleb from Lextego. Accompanying me today is Darshan Gadkari, who is our architect. Darshan will be presenting the latter part of the presentation. Thank you very much for joining us. I'm going to jump right in. We don't have a lot of time and we have quite a bit of ground to cover. We're going to do a quick recap of our journey to date, what brought us to the Actio fraud or financial crime risk management platform, and a brief overview of what that platform now entails. After a year's worth of requirement solicitation, documentation, and then initially also development, we now have a stable platform that we can deploy to start building rules upon. So we're not quite at the stage of an MVP yet, but we have most of our architectural components in place so that we could start adding more content to the platform than the foundational structures. We're going to look at what we delivered during the last program increment, and then also the demonstration we are not going to be doing today, but you may have seen from the chat notes on the Pathable page that there is a video that you could watch in your own time after our session if you haven't found it already. So there is a demo video that you could watch. We have been involved with the Mojaloop community now for about a year and a half. We spend a lot of time doing the requirements documentation for the platform, trying to understand how fraud would be managed in a Mojaloop context. And in our previous PI, all of that work culminated in a proof of concept that we delivered, where we wanted to test whether or not we could actually build an open source fraud risk management solution and achieve certain performance benchmarks and also compose the architecture in a way that would allow us to manage fraud in association with the Mojaloop platform. We achieved our goals, or actually exceeded our goals. Our peak throughput at one point was 8,000 transactions per second. And we had a turnaround time of less than 35 milliseconds for our for the review of a transaction. We implemented 5 sample typologies: SIM swap fraud, scams, account muling, money laundering, a layering example. And then also we did block list management as an example of how interdiction might take place in the platform, where you could block a transaction if the participants were in any way suspicious. This is our current view of the system's context. So we would have your end user customers interacting with their DFSPs, who would then use Mojaloop to switch the transaction between the DFSPs. We are building the platform according to what we call a semi-attached model, where a DFSP or a Mojaloop hub could perhaps submit transactions directly to the transaction monitoring service API of the fraud risk management solution. We are opening that up to DFSPs as well, probably not for the MVP, but the intention is to allow a DFSP to submit transactions that would normally not be seen by the Mojaloop switch, to give a more holistic view of the ecosystem. At the moment, transactions internal to a DFSP is a bit of a blind spot from a Mojaloop perspective, so we needed to create that channel to submit transactions. We're focusing predominantly on the quote as the message in Mojaloop that contains the most information that we would need for a transaction evaluation. But the API and the service is composed in such a way that it is extensible to be able to accept other forms of messages, or even messages from other vendors or other purposes. You could monitor for transactions, or you could monitor participants, or you could monitor even processes. At the moment, we are focusing specifically on building the transaction monitoring service API. As a transaction is ingested through the transaction monitoring service API, we perform the data preparation, where we may enrich that data from additional sources that we have access to. At this point, we won't be doing any data transformation. We expect that a transaction would be submitted in the format that is required, at least from an MVP perspective. And any validation is handled inside the API itself. The transaction is then evaluated for fraud, for financial crime behavior. And we then store those evaluation results and the evaluation data. And we would then allow a investigation services API for a case management solution to collect that information for case management purposes. We would also provide the facility to push that alert out of the system or back to the client systems to let them know that there is a problem with the transaction. This is just a brief overview of the operating model configurations that we considered. And as I mentioned, we selected the semi-attached model, where a fraud risk management service would equally serve a hub operator and or a DFSP. From a delivery perspective, our focus for PI 13 was to finalize our minimum viable product solution design, which we will take you through. We've got the solution design, the concept has been bedded down, and we have started to compose all of the components that are required to deliver on this solution by the end of the MVP. We have designed and implemented the MVP technical architecture, all of the components of that Darshan will take you through in the latter half of the presentation. We've finalized the selection of the technology components. So there are a number of the components that we have agreed to use for our MVP, and we will continue to use them until, for whatever reason, they prove themselves to be suboptimal. Implement ArangoDB for multimodal database support. So we had a challenge in the POC where we needed a graph database solution to be able to handle certain kinds of queries and rules. ArangoDB offers us graph functionality, but also offers traditional relational database functionality. So we were able to use that to fulfill both of those requirements in a single solution. We also spent time implementing our own modular instance that we could use to fire transactions into our financial crime management system for testing purposes. Also to be able to do the performance testing towards the end of the project's development cycle, but also to actually send through transactions simulated in a way that would allow us to detect fraudulent behavior. We implemented a continuous integration, continuous development pipeline. We developed a predicate builder, which is a tool that allows us to easily compose rules in a, let's call it a Lego building fashion. So you could put together the building blocks of the rule and then use that to evaluate a specific transaction. And then we also constructed the end-to-end flow, utilizing all of the components that we had implemented. Some of the challenges that we had left over from the POC, we had some difficulties with rule and typology orchestration. I'm going to skip the next slide, but you can review that in your own time. We had two high-level approaches to managing or to identify fraud, either by centralizing the rules and then calling every rule only once and then utilizing that rule as many times as are required by the various typologies, or embedding the rules inside a specific typology, which would effectively duplicate the execution of the rules, but it's easier to contain the result and the typology into a single unit. That posed a bit of a challenge for us architecturally, the way that we were planning to do the solution from the POC's perspective, and we had made some changes to address the difficulties in the orchestration. We also rooted out unnecessary rule execution. So a rule that not every transaction has to be evaluated by every rule. We built in processes along the way to minimize the amount of rules that are required for a specific transaction so that the solution can function more efficiently. We also found we designed the solution in a way that managed the proliferation of rules and typologies and the associated queues and topics that would follow from that. So we didn't want to end up in a solution where every time you added a rule, you had to configure a new queue or a topic to be able to host that rule's results or to drive the rule. We are still working on improving performance and lowering the cost of scale. Ultimately, it's a lot easier to achieve high scale and high performance if you don't have to worry about what that is going to cost you. But in the environments that we are going to go into, we want to be able to drive down the cost of operating the platform. We can't assume that people would be able to throw infinite resources at the evaluation of the transactions. Implementing graph database functionality is something that we solved for. And also the internal messaging protocols in the platform, we had to decide whether or not we were going to use JSON as the foundation of that. And ultimately we picked JSON, I think. This slide you can view in your own time. Our conceptual design is we have a number of discrete parallel services that we want to provide. Initially, for the MVP, we are building the transaction monitoring service. So you would access that service through an API, and the data processors would handle data preparation, and that's being done in NiFi. Evaluation routing then decides in a number of channels that has a very specific discrete function. We would then route the transaction to all of those channels, and inside the channels, we would then decide which rules and which processes are being executed and at what pace, what is the priority of that channel's outcome. So a specific channel may have to be able to interdict a transaction. Another one needs to be able to provide a response, but not in time to be able to stop the transaction from continuing. And once all of these channels have done their individual pieces of work, we would then need to combine the results into an overall view of the health of the transaction and be able to make a decision on whether or not we need to generate an alert, whether we need to notify the calling system that there might be a challenge, or if there's any work that needs to be done, manual review by a specific user. That happens at the end of the process, but we do provide for the opportunity to hand off an alert earlier. This is a slightly more detailed view of how the channels would work. So you may, for example, have 3 different channels, one channel that focuses on money laundering typologies, one channel that focuses on interdicting fraud. So if you need to be able to interrupt the transaction, and another channel that focuses on fraud that is not interdicting. You may create channels that focus on the quote, or a channel that focuses on the completed transaction after settlement. You may also create a channel that focuses on the participant evaluation. The intention here is to provide for a flexible solution where you can extend that solution as the needs of your organization grows or changes. I'm going to hand over to Darshan now. We're about halfway through our presentation. Darshan is going to take us through the architecture. Thank you very much.
Thanks, Justice, for going through the conceptual design and other slides. So speaking about architecture, before I dive into these components, I want to briefly mention that we kept a lot of design principles in mind, which is cloud native, security first, and as Justice mentioned, design for low budget infrastructure. And also while we do the POC and MVP, and as we go from one PI to another, keep a constant eye on tech debt to make sure we have total cost of ownership as low as possible. Now, when you think about all these design principles, especially cloud native, you can see Kubernetes, no surprise there, or it should not be. For ingress or API gateway, we go in with Ambassador, and for the identity and access management, especially for supporting multi-tenants, we're using Keycloak. Now, the business logic that Justice was talking about is predominantly implemented using OpenFast, which is why you see multiple blocks and multiple containers. And then communication between these functions, right? You saw a lot of these arrows where you have a lot of messages, a lot of information going between rules and typologies, or the channel aggregation and decisioning process, etc. We use gRPC and protobuf or protocol buffers to go along with gRPC for structured data. I will now talk about Linkerd. Service mesh, just is still on that slide. Thank you. So Linkerd is our service mesh. Again, it's an important component. It provides a lot of functionality without having to write any code. And along with Linkerd, we get Grafana and Prometheus. So we definitely will use it for real-time operational metrics and real-time analytics, especially for observability. Now, in terms of doing the data preparation or in the future, other data processing, we've gone with NiFi. And as Justice mentioned, for database multimodal, we've gone with OrangoDB as our transaction database, OLTP. And for long-term or historic observability, we're going with the Elastic platform. And then you have Redis for caching, and then Druid for the analytics, which is OLAP or data lake. And YAML should be no surprise again for a lot of configurations. Just this next slide, please. Thank you. Now, OpenFaaS is where most, if not all of the business logic is hosted. So when we implement OpenFaaS, we wanted to make sure everything is modular and extensible, which made OpenFaaS just a natural choice. I know OpenFaaS, there are alternatives, but when you look at hosting these discrete functions, whether you look at rules, typologies, etc., we want to make sure they work together in an ecosystem, and the working together should be dynamic. Not every rule will send the result to every typology. That's, and then we have many rules and typologies, especially when we're talking about 200+ typologies and rules going into thousands. And each function should be atomic. It should be able to exist by itself, just to work with the design concept and design principle of modularity. Now, when we chose OpenFaaS, we wanted to make sure the code we write is focused on the business logic rather than the plumbing around it, the infrastructure part. And OpenFaaS really provides a good solution for that, especially when you have to expose them internally or externally. And one of the key things in our architecture and our conceptual design is the dynamic typology selection. Not every transaction will have to be evaluated by every typology and consequently every role. And OpenFaaS makes this all happen. Next slide, please. Thank you, Justice. So OpenFaaS, the name should say it all, function as a service. In the POC, we did use the pub/sub architecture. Now with MVP, we went with function as a service. There were a lot of benefits we got by doing that change. With pub/sub, we realized that the infrastructure needs to support millions of transactions, or an ideal use case, it would mean a lot of expense, a lot of infrastructure management, and it was just not realistic, especially for low budget infrastructures. And on top of that, OpenFaaS makes it easy for developers to deploy event-driven functions. You're talking about microservices, especially in a cloud-native Kubernetes environment, with minimal code focused purely on business logic. And it supports almost every popular programming language. And obviously it's open source, so it works really well. Next slide, please. Want to also talk about Linkerd, very critical component, but it's so important and it's so seamless and it's so transparent. It's part of the automation, where when you as a developer, you almost not even see Linkerd, but it brings so much to the table without even you knowing it explicitly, in terms of real-time debugging, real-time observability, security between containers, especially when you're talking about mutual TLS. It's very light, very ultra-light, transparent. You don't have to write any code, low latency, which is very important, especially when you talk about 35 millisecond or other SLAs as part of this transaction monitoring. And it also provides integrated telemetry data collection. You don't have to write much to make this happen. And also execution of control signals within the Kubernetes data plane and control plane. And it plays well with the other components in the architecture, especially gRPC, Ambassador, Keycloak, and OpenFaaS. And as I said, we kept in mind, whatever we did, it was all about low budget implementations. Just this next slide, please. Now, speaking about database, which is critical component, we wanted to make sure we don't have too many databases. So being a multimodal database, ArangoDB just served a lot of use cases, whether it's for configurational data, whether it's for transaction data, whether you're looking at it from a graph structure, relational, also non-relational, as a document store or key value store. To store results, it's also enrichment data from different sources, whether it's JSON based or not. And it's really worked out well for us so far. Now, if you click to the next slide, Justice. Thank you. when we went and picked DynamoDB, we looked at a lot of options. I mean, you can think of how many options that are out there. I mean, there's tons. I can't even possibly list them in the whole presentation, let alone a slide. But for doing a POC to really evaluate, to run some test cases, we looked at JanusGraph and DynamoDB, and we processed 4 million transactions, and DynamoDB just was, almost 20 plus times faster than JanusGraph. And it was just an obvious choice, not in terms of performance, but also in terms of functionality, and it's working out great for us. Next slide, please. And for the demo, since we have run out of time, as Justice said, we've uploaded this, and you can find the video, which you can watch it at your own convenience, and we're hoping to get some feedback from you. Over to you, Justice.
Thank you very much, Darshan. We are at the end of the presentation. The only slide that we have left is the work that we are going to be doing next. We are going to be focusing predominantly on putting the end-to-end security around the system. So bookending the solution with our role-based access control, data protection, and identity and access management. And also implementing our data model throughout the platform, from updating we're creating an adapter for modular loop data. We are finalizing our API to make sure that our data flow internal to the system is ISO 20022 compliant. And we're also going to be looking for available data enrichment services that we could use, and then implement data enrichment as part of the platform as well, that we could then integrate additional data that we could use for rules evaluation into NiFi. And then we'll be starting to put content onto the platform. So we'll be building the rules, the typologies, selecting the kinds of channels that we want to deploy into the environment, and then building rules processes around that. The Apricot work that we had done previously will play a big role here for us in identifying how to triage the rules that we need to execute for every specific transaction. And that's the end of our presentation. Thank you very much for attending. And if you have any questions or comments, please let us know in the chat. Thank you very much, everybody.
Thank you.